Hello guys and welcome at my channel. Today I would like to show you that the derivative of e to the power of x is e to the power of x. Basically we show even more. We are going to show that b to the power of x, so whatever given base to the power of x. Just to remind you, I hope that you remember that if we're talking about b to the power of x, then the value of b is bigger than 0 and b is not allowed to be 1. So we're going to derive all kinds of this function. And as you can see, the trivial case out of this general idea is that if we're talking about e to the power of x, then the logarithm of e is becoming 1, and that's why the derivative is e to the power of x. So let's see whether it's true or not. I started with the so-called h method, and I hope you remember that if we're talking about derivative, it doesn't matter from which side we're approaching our limit, from the left or from the right. So I'm just deciding to take it from the right hand side. So I'm running h towards 0 from the right hand side. I'm using the definition. I'm plugging in the values for my function, and I'm splitting the function in the next step right here apart using the power rules. Now I know that b to the power of xo is a constant value which isn't dependent on h. So using the factor rule of the limits, I can take it out of the limit, which I am doing in the next step, as you can see it right here. So now we're there, and I'm deciding to substitute the variables, to switch the variables. Well, it's a common procedure in mathematics. So we're just, in order to, well, get something easier to handle, we are calling the numerator p, and then we're solving it for h, and then h is becoming this fraction. And in the next step, we are just, well, handling it. We're substituting the values. We're dividing by the green fraction, which means we're multiplying times a reciprocal, if you remember that. And ln b, the value, isn't dependent on p either, so I can take it out of the limit using the factor rule of the limits once again. So I'm kicking those two out of the limit, as you can see. And in the next step, I'm multiplying my green fraction times 1, which I can write the way I like it. In this case, I like 1 divided by p divided over 1 divided by p, which is still 1. And as you can see, those two are giving me 1. And in the denominator, we're just rearranging ln of 1 plus p and 1 divided by p using the commutative law. And now I'm bringing 1 divided by p into the exponent of 1 plus p using the logarithmical properties. And in the next step, I'm just switching p to n, doing this. And as you can see, as p is a very tiny small number, but still positive, n is infinitely big. So this is the limit we're getting right here. So out of p, we're becoming 1 divided by n. Out of 1 divided by p, we're becoming n. And now, as you can see, this is running towards e. So we got ln e in the denominator, which is 1. So this is basically b to the power of xo times ln b times 1. So we're getting to this value. That story, I hope it was clear. I hope you liked it. If you have any kind of question on or something is unclear, let me know. Otherwise, see you guys in the next video. Thank you. Bye bye.